One important part to understand in vector algebra is basis vectors, or unit vectors. And now we go more into mathematics and define x and y coordinates. Each step over x-axis will have its own unique value. Imagine that we cut the x-axis into equal blocks, and they will be given the letter I. And the same will be done to the y-axis. We will also cut it into unequal blocks and give them the name j. From now on, the I and j will define the unit vectors of the two-dimensional xy plane. We notice that I and j will be always perpendicular to each other, with an angle of 90 degrees between them. And orthogonality will always ensure that I.j and j.I will be always 0. And also remember that the amplitudes of these unit vectors are 1. And based on projection concept, we also conclude that projecting I onto j will be 0. And also projecting one of these unit vectors onto itself will give the vector itself. Let's now learn how to represent any vector in terms of these unit vectors. By looking at vector r, we can see that this vector has 2 blocks over x-axis and 4 blocks over y-axis. Then this vector can be represented as 2i plus 4j. Following same procedure, we can represent any vector in the 2D plane in terms of these 2 unit vectors. Now, having a complete view to this vector, we can see that it has 4 blocks over x-axis, 1 block over y-axis. Now, forming the right angle triangle, we can find the amplitude and direction of this vector. Vector addition with basis vectors. To add these 2 vectors, we first form the tail-to-head arrangement. Now, rearranging the basis vectors and counting them, we can simply find the sum of these 2 vectors. With these basis vectors, we can simply visualize the addition process of vectors. Vector components are the components projected onto x-axis and y-axis. Look at this vector for instance. Knowing the angles that this vector make with x and y-axis, we can employ projection formula to know these components. These components are blocks that this vector has over x and y-axis. These components are what we need to define the vector in terms of unit vectors. Summing all things up, we can come to a conclusion. That vector can be represented in 2 forms: polar form and Cartesian form, with these relationships between them. Let's have another example, and see how we can add vectors in both ways: polar and Cartesian. When adding using polar representation, we will not use unit vectors, but rather we would use cosine rule and sine rule to add the vectors and find the amplitude and direction of their sum. But when adding using Cartesian, we start by projecting both vectors onto x and y axis and finding their orthogonal components. And then we add x components together and y components together. Comparing the two answers, we can confirm that both ways lead to the same results. Now let's test dot product in both ways. Starting with dot product in polar form, all we need here is the amplitudes of the two vectors and the angle between them. Now moving to the Cartesian form. With this form, we dot product all I and j components. And based on the orthogonality concept, we come to the same results.